Hello there, I'm Mr. Math Guy, and today we're going to be taking a look at a 10-minute video on inverse relations and functions. So, just a quick definition maybe of an inverse, not a formal definition, but an inverse is some kind of a process to undo something. For example, water freezes and turns to ice, but then if you melt it, it turns back to water. So, freezing and melting, they would be inverses of each other. In math, like addition, if you have a number 5 and you add 3 to it, you get 8. To get back to the original number, you would do the inverse of addition, which is subtraction. You'd subtract 3. So 5 plus 3 is 8. If you subtract 3, you get back to 5. Those are inverses. So that's what this section's about, inverse relations and functions. Now, when we think of inverse relations, think of a relation as an ordered pair. For example, AB or 3, 5, like a domain and range, an X and a Y. So over here you got domain. Your domains are A and let's say 3, and then your ranges would be B and 5. And so A is matched with 5, or B, and 3 is matched with 5. Right? It's an ordered pair. An inverse undoes it. An inverse switches the domain and range. So the inverse is BA, or the inverse is 5, 3. So just to do the inverse of a relation, you just switch your X and your Y. You switch your domain and range. So let's take a look at an example here. If we have this relation 1, 2, 5, 2, negative 3, 2, and I want to first find its inverse, you just switch the X and Y values. So it looks something like this. So the inverse of the relation would be 2, 1, 2, 5, 2, negative 3. You just switch the X and Y values. Now, another question may pop up is this relation a function? Is the inverse relation a function? Well, remember, a function is simply a relation in which your X is matched up with one and only one Y. So all your X's have to be different. So if we take a look at this relation, the first one, these are my domains, and they are 1, 5, and negative 3, and my ranges were here, and they all went to 2. This is a function, right? It is a function because all my X's have one and only one Y. Now, if we look at its inverse, the inverse, you switch your X and your Y's, or your domains, and your inverse is simply, domains is just 2, and now this one is 1, 5, negative 3, and now your 2 is matched up with more than one Y, or your domain is matched up with more than one range. So this one right here would be not a function, all right? Not a function. So we have to kind of understand that just because something is a relation doesn't mean it's a function. Some inverses are functions and some are not going to be functions. Now let's take a look at some notation here. I have this function, or this relation R, and it's the ordered pairs negative 2, negative 4, 2, negative 2, and 1, 4. Now the inverse, the notation for this is like an R. It looks like a negative 1 exponent, but we can't think of that as an exponent. It's not an exponent when we're thinking about inverse relations. It's just a superscript of negative 1. So the inverse then is to switch these X and Y's around. So it would be negative 4, negative 2. It would be negative 2, 2. And it would be 4, 1. I switched all my X's and my Y's around, and I got the inverse. Now, I want to show you what the graph of the inverse looks like. So I graphed the relation points, negative 2, negative 4, 2, negative 2, and 1, 4. And I got those 3 points. Now watch what happens when I graph the inverse. And I'll do them a different color. Now, at first glance, you might not notice anything unique about this, but if I were to draw the line y equals x looks like this. Has a slope of 1, goes through the origin. This is the line y equals x. hopefully you could maybe see something that's something that looks different here, or looks something kind of cool. Notice your black dot is matched up on the opposite side of the line with its purple dot at exactly a right angle. It's perpendicular, right? Same thing for here. This is over 1, so it's going to be there. They're all like this. This is something unique. The inverse of ordered pairs are always flipped across their mirror images to this line y equals x. So if I were to connect the dots here, the black one makes a triangle, the purple one also makes a triangle. They're mirror images across this y equals x line. So if I have a function f of x equals 2x plus 4, what would be its inverse? Again, this is the way that would be notated. What would be its inverse? Well, what you do is you just simply switch your x and your y's. So you'd say, well, this is, instead of 2x plus 4, it's 2y plus 4. Now, we're trying to solve this thing for y, so if in doing that, think of this as just an x over here. This is 2y plus 4. Let's get y by itself, so subtract 4. And you get x minus 4 equals 2y. Then divide both sides by 2. And that would give you x over 2 minus 2, 4 over 2 is 2, is equal to y. Or we would say right here, the inverse of f of x is equal to x over 2, or you could say 1/2 x, minus 2. So let's watch something. If I put the number 10 in here for x, put it in this machine f of x, 2 times 10 is 20, and 20 plus 4 is 24. Now, if I take it through its inverse, then it should go back to 10. So 1/2 of 24 is 12, and 12 minus 2 is 10. So the inverse undoes something. That's why we say we use the word undo. The inverse undoes a function. So the inverse of a function undoes a function. So the definition that we have of inverse functions would say something like this. If f of g of x, a composition function, if f of g of x is equal to g of f of x, and those inverses are equal to each other, and they both equal x, then these are considered inverse functions. So if you remember back earlier in algebra, we have this line, let's say this purple line, and if we want to determine if this relation, these set of ordered pairs, is a function or not, we did something called the vertical line test. And if the vertical line, anywhere we draw it, only crosses one or less, no more than one, then it is a function, right? Now, to determine if something is, if the inverse of this is a function, we could flip it across the line y equals x, right? Here's the y equals x. Remember, it's going to be a mirror image. And we get something like this. Now, is this orange line, is it a function? And we would say yes, because if we did the vertical line test, it would never cross more than one point. So the inverse of the purple line, which is the orange one, it is also a function because it passes the vertical line test. However, instead of having to redraw the graph of the mirror image, there is another test that we can use to determine if a function and its inverse will be functions. And that test is called the horizontal line test. So the horizontal line test says, all right, first of all, we know this purple line is a function because of the vertical line test. It only crosses no more than one point. Now, if we do a horizontal line test and it crosses no more than one, then its inverse will also be a function. So if we take a look at a parabola, and we know a parabola is a function, or at least this one is, because vertical line test, it only crosses more than one point. However, if we did a vertical line test, we would find, oh, its inverse is not going to be. And the reason is, if we switch these 2 points around, the x and y's, then we can notice that we get the same x value for different y values, so it could not be a function. Stay tuned for part 2 of this video.